All right, let's do it. So, my name is Raftopoulos. I've been obsessed with Laravel since version 4. So yeah, I've been through some upgrade guides in my time. At the moment, I am staff and educator at Laravel News, and I also co-organize Laravel Greece Meetup. So a few months ago, I gave a talk at Laravel Worldwide Meetup, along with some other meetup across Europe, about jobs, queues, and workers. So many developers came to me right after those talks, most of them asking the same question. So the question was, what happens when a third-party service our jobs depend on go down? So, that question stuck with me because it's something we've all faced. Oh, here. Something we've all faced. And yeah, so what I wanted to do is I dug deep into this problem, and today I'm going to show you how you can use circuit breakers in order to make sure that your queue system will not fail when external services break down. So picture this. It's 2 a.m. on a Friday night, and your phone rings. Your ops team is calling to tell you that your queue system, your production queue system is down. So you open up your laptop, you check the queues, and you notice that there are 10,000 payment jobs stuck in there. So you check the logs, and you notice that Stripe API went down at 11 p.m. So for the past 3 hours, you've been trying to charge customers, but those jobs time out after 30 seconds. They don't work. Then they retry again, time out again, retrying again, time out again. All of this 3 times. So after 90 seconds, those jobs actually fail. 10,000 jobs, 1 job at a time. So your retry mechanism, the one that's supposed to help you, it's actually making everything worse. So every job that comes in, it's just another 30 seconds that the worker has to wait for. So without circuit breakers, this might take around 24, 25 hours to clear up. It's like a disaster. But if you use something like circuit breakers, in this case, might take maximum of 10 seconds. You do nothing from your side because all happens automatic. So no manual intervention. And the most important thing is that those jobs, those 10,000 jobs we mentioned earlier, they don't actually fail. We just delayed them. So when third-party service comes back online, then they will try again, and they will get consumed as expected. So let me show you how you can build something like this. So we have 3 basic states for circuit breakers. We're going to start with the one on the left side, the closed state. This is our green light. So this means that everything is up and running, everything works. So we still monitor Stripe in the background just to make sure everything works. But all in all, we are in healthy mode at the moment. So after a while, let's say Stripe goes down. And now we monitor for our failure threshold. So when this failure threshold is reached, after, let's say, 5 failures in a row or 50% failure rate, then we open the circuit. And we move from the closed state to the open state. Now, this is our red light. We are under protection mode in this case. The most important thing to understand in this case is that when a new job comes in order to charge your customers, it sees that the circuit breaker is open. It sees that it has to do with Stripe, and it says Stripe is down, nothing to do here, and it just moves along. So we don't send the API request at all. We time out like in 1 millisecond and not 30 seconds instead, and we just fail the job instantly. So no API calls, no timeouts, we just fail. But we don't actually fail, like I told you before. We just delay the job. We use Laravel's release method in order to make sure that we throw the job back into the queue after 30 seconds. And when the service is back online, we're going to retry the job again, so we can consume it just fine. So after 60 seconds, we automatically move from the open state to the half open state. This is our yellow light. Now we're testing for recovery in this case. We allow some test requests to go through, and we check them. So if Stripe is up now, and our requests work, then we move from the half open state back to the closed state, and we're back to normal, back to green. But if those test requests fail for any reason, we move back from the half open state to the open state. And we just retry after 60 seconds. So circuit breaker makes sure that detects those failures fast and fails early in this case. So Martin Fowler, who popularized this pattern based on Michael Naggart's book called Release It, is explaining the core problem perfectly. So remote calls can fail or hang without a response until some timeout limit is reached. So if you have many callers, like 10 workers, for example, or an unresponsive supplier, like Stripe, when it's down, you can run out of critical resources, and this can lead to cascading failures across multiple systems. And this is exactly what we saw in our production scenario. So the many callers is our workers, the number of workers we have. The unresponsive supplier is the third-party service. In our example, it's Stripe API. And the cascading failures is your entire queue system that is now frozen because it waits for those jobs to time out. Let me show you how I've implemented this in Laravel. So we are going to follow a job called Charts Customer. We're going to follow the whole journey of this job, and we're going to see how circuit breakers will help us in this case. So let's go to Charts Customer. Okay, this should be big enough. Perfect. So this is just a standard job. Has some properties up here. We're going to check on them later on. We have a constructor that accepts a customer ID and the amount, which is an integer as well. We also have a middleware in our job called Circuit Breaker Middleware, and we define Stripe as a service in this case. I'm going to check on that in a bit. And the only thing we have in this job is just a mock to Stripe, so we make sure that everything works as expected. I'm not going to go in that, but I want you to notice up here that we have those two properties. The first one is tries, which is set to 0. And this means that the job will keep retrying forever and ever until we clear it out. So it will keep retrying, and the reason behind that is because if you set a specific number here, let's say number 3, because we keep releasing the jobs into the queue, this can fail very fast. So we don't really want to do that. On the other hand, you really want to make sure that if an actual exception comes inside, then this max exception property will make sure that we catch this. So after 3 real exceptions, we make sure that this job fails. So if I scroll down here, we saw this circuit breaker middleware. Let's go in here. We can see that we have the service, which is a string. We can define different kinds of services in different kinds of middleware in this case. And let's go down here. You see we have this new circuit breaker class. And this class is the brain of the whole circuit breaker operation in this case. We allow for a service as a parameter here. And then we do some checks. So the first check we do is that we check if the circuit breaker is open, like we saw earlier in our example. And if it is, we just release the job back into the queue. In this case, we release it after 10 seconds. But if the circuit breaker is in half open state, then what we do is one of the jobs acquire a lock, while all the other jobs that try to acquire this lock get released back into the queue, again after 10 seconds. So the job that does have the lock, what it does is it executes with tracking. And what this means is it can go either way. We can either record the success, like we said, and we go back, we transition back to the closed state, or we record the failure if we go back to the open state in this case. So if I go to record success, you'll see that we do check if state is half open, and if it is, we just go back to closed, because now everything is back to normal. Everything works in this case. and we just force release the lock. But in case there is a failure in those test requests, we go back to the open state. The way we identify the failure rates or the number of failed requests, the failure threshold, is we have a bucket of 1 minute. So every 2 minutes, we reset everything. We reset our cache, the place where we check the window, the time window. Every 2 minutes, we get a new window in this case. So everything needs to happen inside this minute. So let's go up here and let's go to this function down here. So the way that we identify the failures, like I told you, is that we need to make sure there are actual exceptions. So if, for example, there is a failure like a 429, 401, 403, all those kind of client-side exceptions, this means that the issue is on our side. So maybe a misconfiguration, a missing API key. This is not an actual issue. It's not a third-party service issue. But we do account for every other server-side exception, including timeouts as well, of course. This is a real exception in our case. So the way we transition between states, I remind you that we have 3 basic states. We have closed, we have open, and half-open state. It's pretty straightforward. So what we do is we acquire a lock, we check on which state we are, and at the end, depending on which state we are, we actually dispatch a new event. So the circuit state, when it's open, it dispatches the circuit break open event. Same for the half open and closed events as well. If I go deeper here into this event, we just allow for 4 properties. The service with the string, the failure rate, the number of attempts, and the number of failures, of course. You can catch this event and you can do whatever you want with it. You can notify your customers, you can notify your admins, your Slack channel. You know that the third-party service you depend on is currently down, and you need to act on it. So there is also some configuration you can do in circuit breakers. I have this configuration file called circuitbreaker.php, and here you can enable or disable circuit breaker pattern in general. You can also define some thresholds, some default thresholds, regardless of the service. So let's say you can have 50% failure rate. You can define the timeout. It's 60 seconds in this case. That's the default. And we also have a minimum number of requests before we evaluate for the threshold. We set 10 in this case. And not only that, but you can also configure that per service, of course. So I do have some configuration specifically for Stripe service in this case. You can change timeouts, you can change the minimum number of requests only for Stripe service. And you can also define peak hours because your app might be in heavy load during 9 to 5. So you can also define different configuration for those specific hours as well. So that's what I wanted to show you regarding code in this case. It's pretty straightforward. The next thing I would like to showcase is that I built a Laravel app based on that. So we're going to see 2 scenarios. The first scenario is a disaster scenario where we have too many jobs inside the queue. Stripe fails, but we don't have circuit breakers. While the second scenario will be exactly the same, but this time we will be using circuit breakers. So let's go ahead and do that. We will be using Horizon for our queue system, so I'm going to boot up Horizon right now. It's a standard Horizon instance. I don't have anything more other than the default queue in this case. And we start with a clean slate, so no jobs in there yet. The interesting part here is that I have this control panel. And what this control panel does is it shows us what's the state of the circuit at this point in time, Stripe API, if it's healthy or not, and if we are under protection or not. So if circuit breakers are enabled at this point or not. We refresh every second, so we see this in live. I also have a status page where we can see how the states changes and the history of those states. We're going to see the number of attempts, the number of failures, the failure rate, and we also have the minimum number of requests set on the bottom right corner. So the first scenario again is I'm going to dispatch thousands of jobs into our queue. So I have 7,000 jobs at the moment. And you can see here that the number of jobs goes down because I do have a sleep of 3 seconds in them, so they get consumed just fine, which is ideal, right? But at some point, Stripe API breaks. Let's disable circuit breakers to begin with. That's the first scenario. So now Stripe API breaks, right? So I go back to Horizon. And now you'll see that the number of jobs will stop going down that fast. It will actually take 30 seconds for each job to time out. Then it will retry again a couple of times, timing out again, etc. So this is really a disaster scenario in this case. These 7,000 jobs might need tens of hours to clear because they will time out, and it is very prone to cascade and take down your entire queue system. And every other job that tries to go in this specific queue is actually blocked as well. So I'm going to stop Horizon now. I'm going to clear it up and start again. So we start with 0 jobs. Let's go back to our control system. I'm going to reset everything. And now we do have circuit breakers enabled in this case. We're going to dispatch again thousands of jobs like I did before. Let's see how many we have. 7,000, it's good. And now I'm going to simulate again the Stripe API is down. So Stripe is down. Let's check the status. You see the number of attempts goes up. Number of failures goes up as well. Failure rates going up. And at some point, when we have the value of our configuration hit, so the rate limit is hit at this point, the failure rate, you'll see that we will change from the closed state to the open state. Boom. So that's it. We're now under protection mode. We went from the closed state to the open state. So the circuit breaker for Stripe specifically is now open. And if I go to Horizon, there are no jobs in there because now circuit breakers protects us and they release the jobs after 10 seconds based on the configuration. So you see the number goes up and it will go down to 0 again. So because it keeps retrying until Stripe API is back online. And this happens automatically with 0 manual intervention from your side. Let's go back to status. You see that we went from the open state to the half open state and back to the open state because Stripe is down again. Now let me go back and say that Stripe is healthy. So now we're currently again going to try to transition from the open state to the half open state. We're going to test for recovery, and because Stripe is up, our system goes back to the closed state. So the circuit breaker is now closed. Everything is back to normal. Our app is healthy again. So if I go back Horizon, all the jobs are back into the queue. 0 intervention from your side. And this state management gives you the ability to make sure that you don't get paged at 2 a.m. in the morning. So, when to use circuit breakers? You can use them for external dependencies that can fail, hang, or timeout. Things like payment gateways, like Stripe or PayPal, communication APIs, like Twilio or Mailgun, microservices that are outside of your control. Don't use them for things like database queries or internal method calls. You can use different patterns for this. So, what to do when circuit is open? Stripe API is down. The circuit is open. Now what? You need a plan. You can return cached data. You can use a fallback service. If you have a fallback payment gateway, now it's the time for you to use it. You can queue them for later, like we did earlier. Or you can use graceful degradation, because sometimes the best feature, if the third-party service is down, is not to show the feature at all. Build production systems that don't break. So when external services fail, circuit breakers protect your queue. And when the service recovers, circuit breakers handle it automatically. And when you're sleeping until in the morning, they keep your system running. That's the power of resilience. So I have bundled all of this in a package called Laravel Fuse, in a Laravel package. And yeah, we are going to release this live on stage, of course, why not? I'm going to open source that. It's now closed source at the moment. So let's go in our settings. Let's go down, change visibility to public. Yes, I understand. Oh.
All right, thank you very much.
Wait.
Oh. That's why I was standing here.
I guess some more. Yeah, wait. Give me a moment. We don't have the passwords. Oh, well. Too much security. Okay, I'm going to release this now. Okay, now. GitHub, yes. Let's copy the password, of course. Let's do it. Let's go right in. Yes. Did it work? Yes. So, I have one more slide. Can I do it? Yes, thank you. You can also scan this QR code. You can find all the information, all the resources from today. I also include Martin Fowler's original article, and I also include Michael Naggart's book called Release It that popularized this whole pattern. And you will also be able to find all my social media with the tag Harris Rafto mostly, especially my YouTube channel where I try to post free Laravel quality content. And that should be all for today. Danyavan. Thank you. Now you can come.
Shukriya. Did you say like Kem Cho? You have to repeat what I said to everybody, okay?
Yes.
તમે બધા
તમે બધા
જોરદાર
જોરદાર
વ્યક્તિત્વ
વ્યક્તિત્વ
ધરાતે
ધરાતે
હો.
હો.
A
I don't know
man
what
with,
this is, but,
yeah, the man with muscles, the man with power. So are you ready to fill in the blanks?
I'm ready. Yeah.
So for you, it's fill in the blanks.
Cool.
So the statement will come and then you have to just go ahead with the answer. All right? So you can come this way.
I will come this way. Okay.
Okay, Bhavdeep, can we start? Okay, let's start. Number one, most production failures are not technical, but caused by
Human intervention.
human intervention. Perfect. Second, the biggest myth about reliability is
That it exists.
that it
Exists.
wow. I like this. I like this kind of answers. Very good. Yeah, we are doing pretty good.
let's
Number
do it.
three, the number of people I want to interview during these 2 days is
You.
Yeah.
That's
the total number of people.
the total number.
Yep.
Okay. As many as I can.
As many as you
As
can,
many
but
as
these
you can.
people have a lot of energy, bro. You'll
Yeah.
get tired of it.
Yeah, no.
Will you?
I
No?
will never get tired of it, no.
So how many of you would like to have an interview with him to come on Laravel News?
Oh, nice. Okay. That's
Very good.
many.
Ben, તમારે નથી કરવાનું?
I don't bite. Come on.
બકા તું eagle છે, eagle. And what does eagle do? Rebirth. So you're going to rebirth tonight.
Yes.
Garbama especially. Number four. One thing every system should be designed to handle is
Downtime.
downtime. Very good. Number five. Teaching others helped me to learn. Teaching others helped me to learn.
Consistency.
Consistency. Very good. Number six. One habit that allowed me to become successful is.
Consistency.
So for
Consistency.
consistency.
Again, yeah.
Very good.
For
So you are
everything.
consistent in what you do.
I try to be. Yeah.
Very good. Number seven. Being active in Laravel community has taught me
Empathy.
empathy.
Yes.
Very good. बहुत अच्छा. Number eight. One of the biggest things I've learned from Laravel News is
Be the first to cover the news. That's the idea.
Be
The first one that will cover the news.
okay, be the first one who can cover the news. Yeah, so you always do the breaking stories.
Yeah.
Number
That's
9, the biggest lesson failure teaches us in.
Never stop trying.
Never stop trying, so keep trying.
Yeah, keep trying.
Very good. Number 10, last question. When I think of Laracon India, the first thing that comes to my mind is
Energy.
energy.
Energy, for sure. For sure.
So show us your energy. Yeah,
Then you see.
we have seen it, but we want to see your energy
You're gonna
once
see
again.
later in the Garba.
Yeah, so you're going to play Garba? Great, so
course.
we'll see you in Garba as well for sure.
I don't know what it is.
How many of you are excited to play Garba? Wow, nice. Huh? So, one question for you from Chirag.
Yes.
What are the common mistakes teams make when implementing circuit breakers in Laravel? And how can they detect those mistakes early in production?
So, I think misconfiguration is
Misconfiguration.
you need to find the right balance between timeouts, failures. When it's the peak hours, your traffic and everything comes in. I think that's the main thing. And what's the second part of the question?
Second was like, how can they detect those mistakes
How
early in
did-
production?
Okay. With trial and error, I think. You need to try it out. Probably in some staging environment first, and then move it on to production. But you definitely need to try it out. Just stress test it, just to make sure that everything works as expected.
Okay, perfect, Harris. Congratulations for your first successful talk.
Thanks, man. Thank you.
Bye.